Now we can see in this session role of dielectric material in the capacitor. As we know that dielectrics plays a very important role in increasing the capacitance of a material. So for that purpose we can take a parallel plate capacitor and which is connected to the battery. And because of this applied electric field, what happens, these parallel plate capacitors, the charge will be induced, and the induced charge we can consider it as a Q, and the voltage applied across these capacitance can be considered as a V. And we know that, so in between the capacitor plates there is no medium. Let us assume that it is a air medium. So in presence of air, the capacitance can be considered as Q by V. And in addition to that, the capacitance can also be written as based upon the area and distance between the two plates. So if A is the area of the plate and D is the distance between the plates, then in the air medium capacitance can also be written as epsilon naught A by D. So epsilon naught is the permittivity of free space. Now if you introduce any dielectric material in between the capacitor plates, then what happens is, so the charge on the capacitor plates doesn't changes, but whenever you apply the dielectric material, the atoms will get dipoles, converted into dipoles, and we are applying the electric field in this direction, then what happens, the atoms get dipoles in the opposite direction. So then in the opposite direction some voltage will be produced due to the introduction of dielectric material, and in this direction some voltage will be there. So net voltage will be decreased. So automatically whenever the dielectric material is introduced in between the plates, the charge on the capacitor plates doesn't changes, but the net voltage will be decreased in between the capacitor plates because of the dipoles creation in the dielectric material. So hence that net voltage can be written as a Vd. So as the voltage decreases each and every time, the capacitance will be increased. So the same relation as per the dielectric constant of the material, C suffix D can be written as epsilon A by D, because when there is no medium in between the capacitor plates, we have written the epsilon naught. If there is a medium in between the capacitor plates, we can write the permittivity of that particular medium. And we know that epsilon can be written as epsilon r is equal to epsilon by epsilon naught, and that implies epsilon is equal to epsilon r into epsilon naught. So if you can write here epsilon r into epsilon naught A by D, and C suffix D is equal to epsilon r into, instead of epsilon naught A by D, we can write the capacitance in a air medium. Hence whenever you introduce a dielectric material, the capacitance can be increased its dielectric constant times. So in the same way, if you can write C by CD in terms of voltages, Q by V by Q by Vd. So Q get cancelled, C by CD is equal to Vd by V, and C by CD is nothing but inverse of epsilon r Vd by V. So whenever you introduce a dielectric material in between the capacitor plates, the voltage will be decreased epsilon r times, and the capacitance may increased epsilon r times. So like this we can increase the capacitance of a capacitor by introducing the dielectric material in between the capacitor plates. Hope you understand this session.